Today we are talking about how to solve linear inequalities and also how to graph it. Solving linear inequalities are very easy since we discussed inequalities in our previous lessons. Also, we had an extensive lesson on linear equation. Knowing both subjects make it easy to solve a linear inequality. But first, let's overview the concept of inequalities briefly. We know that there are 4 signs for inequalities. So when A is less than B, when A is less than or equal to B, when A is greater than B, when A is greater or equal to B. The unique thing about inequalities is that there is not just one solution, but there are multiple solutions for inequalities. Think about the following inequalities where x is greater than 3. What that means? It means you can replace any number that is greater than 3 for these inequalities, and the value of inequality wouldn't change and the statement remains true. Let's say we put 4 instead of x, or 5 instead of x, put 10 instead of x. All of them make this statement true. Also, we can show it on a number line. And let's say we have a number line where 0, 1, 2, 3, 4. Let me clear this section. And 5, 6, 7, minus 1, minus 2, minus 3. So, as you see, 3 is located in this section. We locate our 3 here and with an open circle, and whatever number comes after 3 can make this statement true. As you recall, we use open circle because 3 itself doesn't include in these inequalities. But whatever number is greater than 3 make this statement true. Now, let's say we have an inequality and like 2y minus 5 less than 7. And we want to solve this inequality. We are going to solve inequalities exactly the same as we solved equations with the same techniques, which are first simplify each side if needed, then we use subtraction or addition to move the variable terms from one side to the other side, and then use multiplication and division to remove any values that are in front of the variable. So we have 2y minus 5 is less than 7. The first thing we do is add 5 to both sides. So we'll have 2y minus 5 plus 5 less than 7 plus 5. These two cancel out and we'll have 2y less than 12. We divide both sides by 2 and we'll have y is less than 6. Right? Now we can draw it on our number line. Let's say we have 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is minus 3, minus 4, minus 5, minus 6, and this is infinity. Okay. Now we mark our 6 which is here. And so y is less than 6. So all the numbers which are less than 6 can make this statement true. Let's do one more example. Let's say we have 3x plus 1 greater than 4x minus 2. First thing, we get rid of this plus 1 by subtracting it from both sides. So 3x plus 1 minus 1 is greater than 4x minus 2 minus 1, right? So we'll have 3x is larger than 4x minus 3. The next step is to simplify this inequality. For that, we subtract 4x from both sides. So we'll have 3x minus 4x larger than 4x minus 4x minus 3. Then we'll have these two cancel out. Then we'll have minus 1x larger than minus 3. Now I need to have a positive x, so I'm going to divide both sides by a negative 1. So we divide both sides by a negative 1, and we'll have x is less than 3, right? When we divide or multiply and that one with a negative number, we need to flip the sign. The reason we flip the sign, if you recall, is the value, when we divide or multiply by a negative number, the value of the number will change. Let's say, let's review the concept. One book, which is less than 2 books, right? So if we multiply both sides by a negative number, let's say by a negative 2, then we'll have 2 times 1 is minus 2, and 2 times minus 2 times 2 is minus 4. Now, is this a statement true? No, it's not this true statement. We know that minus 2 is larger than a minus 4. So we have to change the sign when we multiply by a negative number. So when we multiply by a negative number, we need to flip the sign and have minus 2 greater than minus 4. And this is a true statement. Now let's finish our problem. We have x less than 3. Let's show it on a number line, and this is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5. Now x is less than 3. We locate our 3 here. Since x is less than 3, we need to put an open circle around 3, and it means that 3 is not included. All the numbers that are less than 3 make this statement true. Now let's do another example. Let's say we have 4 minus 6x larger than or equal to minus 15 plus 1. Again, we start by simplifying the whole inequalities. So we'll start with, we can add these two and have minus 14 less than or equal to 4 minus 6x, right? Now we subtract 4 from both sides, so we'll have 4 minus 4 minus 6x then or equal to minus 14 minus 4. Then we'll have these two cancel out, minus 6x then or equal to minus 18. Now we divide both sides by minus 6, and again Since it's a negative number, we flip the sign and we'll have x is less than or equal to 3. Now we draw it on number line. We'll have 0, 1, 2, 3, 4, 1, negative 1, negative 2, negative 3, negative 4. And so any number that is less than 3, including 3, because it's equal to 3, can make this statement true. So we draw our numbered line. We make a closed circle around 3 because it is included in this statement and it can make this statement true. So all the numbers, including 3 and less, can make this statement true. Now, let's see if we can solve this one. Y is less than or equal to 4x plus 3. What about this one? Based on previous lesson, when working on linear equation, we know that the most common form of linear equation is slope-intercept form, which is y equals to mx plus b. You can see the similarity. We have intercept here. We have variable has to be known. We have also slope. And the only difference between these two is the sign. For linear equation, we have equal sign, unlike the inequalities. So we solve it very much the same way we solve a linear equation. In a linear equation, we have two sides of equation that are equal. Then we graph it and the line is straight, right? While in a linear inequality, we have two sides which are not equal. The line on the graph cannot satisfy our equation. So we need to consider an area instead of just a line. So we draw a boundary as a line instead of a straight line. Let's solve this one. Y is less than or equal to 4x plus 3. What does actually it means? It means y is can be less than 4x plus 3, and also it could be equal to 4x plus 3, right? Now, we know how to graph y equals to 4x plus 3, right? We start from that point. So we draw our coordinate. This is our x-axis, and this is our y-axis. So we start with our intercept, which is 3. This is our intercept. If x runs by 1, y rises by 4. 1, 2, 3, 4 here. If x runs by 1, y rises by 4. 1, 2, 3, 4 is going to be here. If x runs by 2, y is going to rise by 8, right? So we can go to opposite direction. When x runs by 1, y drops by 4. When x runs by 1, y drops by 4. So we can draw with these couple of points, and the line looks like this one. Now, our inequality includes y is less than 4x plus 3, right? So let's think about it, what it actually means. It means if I pick some x values, y is less than that a number that we get from that value. Let's say we pick x equals to 0. Then 4 is times 0 plus 3 is going to be y less than 3. If I pick x equals to minus 1, then 4 times minus 1 plus 3, y would be less than minus 1. If I pick x equals to 1, then 4 times 1 plus 3 is less than y is less than 7. If I pick 2 as x, then I have 4 times 2 plus 3, y is less than 11. Now let's graph this one. If x is 0, y is less than 3. So if x is 0, y is less than 3. It means all the points down here satisfy this inequality. So now the second point is x equals to minus 1. If x is minus 1, then y is less than minus 1. So if x is minus 1 here, y is less than minus 1. So all the points down here make this statement true. If x is 1, y is less than 7. So 1, 2, 3, 4, 5, 7. So all the points below this line will satisfy this inequality. Or if, let's say, we have the x equal 2, then y is less than 11. So if x is 2, y is less than 11. 1, 7, 8, 9, 10, 11. The graph is not accurate, but it looks something similar to this one. So it means all the points below this line is going to satisfy this inequality. Now that we graph this inequality, we essentially can say that all the area below this line that I'm shading in orange is going to satisfy this inequality. That includes the line because y is less than or equal to 4x plus 3. So the line itself satisfies this inequality and all the area below that. This is our inequality that we have graphed. Now let's graph another inequality. Let's say we have y is greater than minus x over 2 minus 4. An easy way to look at this inequality is to consider it as equation and then graph it. Let's see how it works. This is my x-axis and this is my y-axis. The intercept is minus 4. 1, 2, 3, 4. This is my intercept. So the slope is minus x over 2, that we can write it as minus 1 over 2. It means if I run by 2, I go down by 1. Run by 2, down by 1. If I go in the opposite direction, it means if I run by 2, rise by 1. Run by 2, rise by 1. So the line would be something similar to this one. But remember, our y is not equal. Rather, it's greater than negative x over 2 minus 4. It means that if you pick any x value, it's going to be greater than the point on the line. So first the first thing is we have to make it to a dashed line. Let me make it to a dashed line. But remember, our y is not equal. Rather, it's greater than negative minus x over 2 minus 4. So it means if you pick any x, let's say you pick, for instance, 4, then that point is going to be greater than this point on the line. So let's say we have x equals to 4, right? Then we solve for this one. We'll have minus 4 over 2 minus 4. Then we'll have minus 2 minus 4 equals to minus 6. So if you have x equal to 4, then the point is going to be on the line. But what we care is all the area above this line as y. So we put an open circle around this point, which means this point is not included in this inequality, but all the number that is greater than this one is going to be above this line, will satisfy this inequality. So let's work with another inequality. 2y less than or equal to 24. We have seen this before. We first figure out what the equation looks like and then rearrange it to see what less than or equal means instead of equal. So first let's rearrange it and write it in slope-intercept form. First we subtract 3x from both sides, then we'll have 3x minus 3x minus 2y less than or equal to 24 minus 3x, right? Then these two cancel out. We'll have minus 2y less than or equal to 24 minus 3x. We can rearrange this and we'll have minus 2y less than or equal to minus 3x plus 24. Now we divide both sides by minus 2 and minus 3x minus 2 and 24 minus 2. We'll have these two cancel out. We'll have y, and because it's a negative number, we flip the sign. We'll have greater than or equal to minus 3x divided by minus 2 is 3x and minus 12. Now we are ready to graph this one. Let's graph it. Let's see. The graph is too small, but we can work it out. The 11 and 12. So the intercept is 12. So when you run by 2, you go up by 3. Run by 2, up by 3. Run by 2, up by 3. Run by 2, up by 3. So the line looks something similar to this one. But since we have y is greater than or equal to this line, the area that satisfies this inequality is going to be above the line. So all the area above this line is going to satisfy this inequality. It means for any x you pick, this is going to be a value for y. Now you are ready to do some practice at home. Graph the following inequalities. Let's say we have 4 minus 6x greater than minus 15 plus 1. Y is less than 2x plus 2. 3y is greater than or equal to 2 minus 4x. Y is less than 2x plus 1. X plus 2y is less than or equal to 8, and y is less than or equal to x plus 4. So now let's talk about a system of inequalities.